Today I am going to cover the topic called post correspondence problem. So, topic is post correspondence problem. Before moving on to the problem, let's understand the definition of it. Okay. So, first of all, the post correspondence problem PCP, in short PCP, is introduced by M.L. Post in the year 1946. Okay, it is an undecidable decision problem. So, as the name suggests, it is an undecidable decision problem. So, you cannot decide whether you are going to get a solution or not for the particular problem. So, you may get a solution or minimum may not. For all problems, you will not get a solution. Okay. So, PCP problem normally defined over an alphabet sigma. So, every time you need to be, so problem need to be defined with a certain set of alphabet. It is stated as follows: given the following two lists x and y. So, in the problem they need to give you a list x and y of a non-empty strings over sigma. Suppose sigma is 0, 1, xy is a sequence of same length, You can see here x and y is a sequence of strings x1, x2, x3 and so on until x1. Suppose if the alphabet is 0, 1, then your sequence can be 0, 1, 1, 0, 1, 1, all these. So, this will be x1 and this will be x2 and this will be x3. Okay. And remember, for every xi's you have corresponding yi's. So, it will have also, and that is also defined over alphabet sigma 0, 1. Okay. Something like this. So, now here you can observe here, if the length of the x list is 3 and here also y also need to be 3. Okay. The length need to be same. Okay. And now what is our aim? Our aim is to produce string or a solution using xi's and yi's. Produce a solution using xi's and yi's. How? So, your solution should be equivalent. That is, whatever the solution you are getting from xi's will be equal. Suppose if you have taken 0, 1, 1, okay, and whatever that is 1, this xi solution should be equivalent to yi solution. Whatever solution, you need not take in the same fashion, same order. X1, there is no compulsion that x1 also only you have to take always first. You can take anything, but ultimate what you are going to get, you are supposed to get one string out of x1, x2, x3. Okay, any order you can take. Beginning you can take x2 or next you can take x3 or x, any order you take. Finally, the corresponding yi's also need to be same. And remember, whenever you are picking this element or this tail or this domain, this particular problem is similar to game of dominoes. Okay, Okay, and let me complete the definition here. We can say that there is a post correspondence solution if for some I1, I2, Ik where 1 less than equal to ij, 1 less than equal to n, the condition xi1 to xik should be equivalent to yi1 and yik. Is it clear? So, whatever the strings produced by xi should be equal to yi's. And remember, you can even take particular maybe xi's any number of times, that is allowed. Okay, you can take this one or more times, and there is no compulsion that you have to take all the elements to produce a string. Is it clear? Next, let me take one first problem. Does the PCP PCP with two lists x, y, b, BA, BQ, BA, B cube, BA, A. Have a solution. This is the first problem I am going to solve. And remember one thing, the list can be produced in several ways. List can be given in several ways. One, it can be in a table format. Okay, one in a list format as I have shown here, and one in the table format. What is table format? There x and y is given, and for b, what is the corresponding yi? That is b cube, and for BA, B cube, then you can write BA, then BA and A. Okay, this is the way table format also you can get, or sometimes in the list format also you can give, and in the tile format, dominoes format. What is the dominoes format? That is like this: B, BA, B cube. Okay, that is, this is 1, this is 2, and this is 3. How many we have? We have here 3 elements for xi and yi's. So next, for second element is BA, B cube, BA, then BA and A. So now, how do I find the solution for it? So these are the various representation. You can represent the problem in terms of list, or in the table format, or in the dominoes format. Any format you can, but your ultimate aim is same. That is, you have to get a solution. You have to generate a string, and both should be equivalent. Okay, xi string and yi string need to be equivalent. So for this, how should I start? I can start from here, from B. Let me take the first element of x and y. So what it should be? That is B. If I take B, the corresponding need to be B. So this and the first character is equal. In this, first character is equal, isn't it? I cannot take the third element as third element in the beginning. Why I cannot take third element in the beginning? Because the first character itself gets mismatched. So then there is no point in continuing with that. So now the next I want here, along with this, since I have considered here this is fixed now, next I want as B. So only two choices that can give you the first character. B is, one is by again picking the first element, and again or picking the second element. So you can take any one. Okay. So if I take, let me take the second element, what happens? Can I continue with the second element? If I choose the second element now, then it is going to give me B, A, B, B. So what happens? The third character gets mismatched. So that means I cannot take the second element. I cannot take the second element after taking the first element. So then is it, let me repeat again. So let me check whether after repeating the same sequence, B and B cube, B, B, B. Okay. So next, can I add this element now? No. Obviously, third element is not possible, B, A, B cube not possible. So if I continue with this, it is keep on moving. I cannot, so this obviously is not allowing me to take the second and third element. So this is going to proceed like this, repeating a sequence of unequal elements, unequal characters. So which is not required for us. Okay, we want the same string generated by both xi's and yi's. Next what I will do? I will start taking the first element as B cube and BA. B, A, B cube in the sense this, and then BA. I start with this element. Okay, I got to know that using one I cannot get the solution. I'll try with this B cube and BA. So next, which one I should take? Next element I want here is B. So that means I have to look at the yi's, isn't it? So the best one I can get is using the first element, So first I used the second element. Next I am going to use the first element. So that is B, and then B. So next, which one I should use? There are two possibilities now here. That is I have to get here B in the yi place. That means I have to look at where I can get the which yi's I have to use. So now whether to use the first element or second element. So let me try with this B cube and BA. So if I write here B cube and then BA, what happens? It is not going to give me a solution. You can see here, you get a mismatch at this character. And it is like a trial and error method. So I will delete this. Then again I will use the first element again. So the next again I will use the first element. So B cube. So now I want, see here, now yi is increasing. Length of the yi characters are more than the xi. So now I should look at this position and decide the next probable element to be used. So next probable element to be used is maybe this. This is better, isn't it? So if I use here B and then BA and then down A, what happened? You got a string from a xi and yi which are equivalent. So first I used 2, next I used 1 and then 1 again, and the last I used 3. So sequence what you got is, to obtain the string is 2, 1, 1, 3. 2, 1, 1, 1, 3. This is the solution. Similarly, remember there exist many solutions also. Not only one solution. If possible, you can get a many solution. And remember here 2, 1, 1, 3. If you keep repeating 2, 1, 1, 3, you can get one more solution. That is also possible. Not only one solution. 2, 1, 1, 3. Again, I'll use 2, 1, 1, 3. This can give me one more solution. Again repeat and you can get the third solution. This can also be continued, or some other solution also you can get, but you have to try in a trial and error way. So this is one problem. Next I will show you another problem. Prove that PCP with two less x equal to 0, 1, 1, 1, y equal to 0, 1, 1, 1, 0, 1, 1 has no solution. Now we have to find, is it possible to get a solution out of it? So let me start from 0, 1, 0, 1, 1. And one thing is clear for you, that it has no solution, okay, from the question. So, but still let's check why it's not having any solution. 0, 1, 1, with 0, 1, 1, if I try to add some other element, 1, then 1, 0. So again I should get 1, 1 and 1, 0. Not possible, not possible. So next if I try with another element, 1, 1, 0. So 0, 1. So 0, not possible. If I start with the second element, I cannot continue further. Then the third element, 1, 1, 1. So it is obviously it is not allowing us to take the third element, because the second character you want is 0. The second character you want is 1, sorry, 1. So only thing that it is keep repeating, and obviously you can see here properly. So every time the whatever the length of the string, if you observe, the xi's are shorter than the yi's. Xi's are shorter than the yi's. That means you can see here, for all i's, that means for all elements, first element, second element and the third element, the length of xi is less than length of yi for all I. Okay, so this is unacceptable. So if the length of xi is less than length of yi for all I, then you cannot have a solution. Even if it is length of xi is greater than length of y, it is you cannot have a solution. So then this is about, it can't have a solution as length of xi is less than length of y for all I. Next, I'll move on to the next problem. Does the PCP with x equal to b cube ab square and y equal to b cube ba b cube have a solution? For this problem, we can have a solution. As x1 equal to y1. What is x1 equal to y1? That is b cube equal to b cube. So the sequence can be with 1, or you can repeat 1 1 and you can get many solutions. So this particular problem has a solution. Let me take one more problem. Find at least 3 solutions to PCP defined by dominoes. 1 1 1 1 1 0 0 1 0 1 1 1 1 0. These are the dominants, and we are supposed to, I have told you that I have to there is a solution. So what, at first let's find at least one solution. First, let's find at least one solution. What is that solution? So, let me, what if I start with 1? What if I start with 1? 1, 1, 1, 1. So, can I get with this? Can I add the second element? So obviously I cannot start with the second element because as the first character itself is mismatching. So I cannot add 1 0 with 0. So here next 1 0 1 1. No, I cannot take the third element also with in continuation with the first element. So if I take one more time 1, if I take one more time 1, that is the first element. So again it is repeating 1 1 1. So again I cannot take the second element, I cannot continue with the third element. So because the length of the xi becomes shorter. Okay, so I cannot have a solution with the first element. So then I will check with the, what about the second element? Obviously it is not possible. Then I will start with the third element. Let me start with the third element. 1 0 1 1 1 1 0. 1 0 1 1 1 and then 1 0. Next, which is the right element to choose? Whether to choose the first element or whether to choose the second element or whether to choose the third element, because here you want 1. So and I cannot take third element again because it is showing here 1 0. The numerator should come 1 0. So if I take 1 0, so obviously you can get a mismatch at the fourth character. So that's why I will take the first element. So 1 1 1 1. Next I have to get one more element. I have to take one more element either, and the first, this character has to become 1 in the numerator. So either I can go with this element, first element, or I can go with the third element. But I will prefer to choose this time the first element itself. Again I will choose the first element. 1 1 1 1 1 1 1. You can try with the third element, choosing the third element again, but I prefer to choose 1 again. Then can I have a solution with the other element? So now I will prefer to choose the second element. Which element? Second element. So this will give me 1 0 0. So this is going to give me, that is this sequence 3 1 1 2 is going to give me a solution. So xi and yi are equal and this is a solution. The solution sequence is 3 1 1 2. This is one solution. Then if you want more solution, then you have to repeat the sequence. So by repeating sequence 3 1 1 2, we can get more solutions. So the next problem I'm going to take here is m equal to and n equal to a b b a. List name can be anything. X and y is just for the definition I have used. So a b b a b b a. So find whether the list have a post correspondence solution. correspondence solution. Let me first take the second element A, 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 A. First sequence what I am going to consider in this manner. First I will consider second element. Then I will have to consider the second element. First element, that is A, B, B, then B, B, A. So 2, 1 and then I will consider the third element because I want here A. The best matching is either this or this. So preferably this to get a solution. A, A. So we have a solution. We got a solution with the sequence 2, 1, 3. So we have here a solution. Solution gives a sequence 2, 1, 3. That is x2, x1, x3, which is equal to y2, y1 and y3. And you can even get a solution with 2 and 3. Find the solution, find the PCP solution for the following list. AB, BAB, BB, AAA. So A, BA, BAB. Find whether you have a PCP solution for the following element. Find whether the following list have a PCP solution. Following lists have a PCP solution. So for this particular problem has no solution. There is no solution for this, since length of xi is greater than length of yi for all I. The last problem which I am going to give or solve here is A equal to 1, 1, 1, 0, 0, 1, 1, B equal to 1, 1, 1, 0, 0, 1, 1, 1. Whether these lists have a PCP solution. Whether these lists have a PCP solution. So here I have modified in the y3. So now here we have a solution with 1, 1, 1, 1, 1, 1, 0. First I have added 1. Next I am going to add 2, 1, 1, 0, 0, 0, 1 and finally 0, 1, 1. So this is going to give me a solution with the sequence 1, 2, 3. So that's about PCP correspondence problem. And the last statement which I am going to give on MPCP. So what is modified post correspondence problem? If the first substring used in PCP is always X1 and Y1, then the PCP is known as modified post correspondence problem. Then the PCP is known as MPCP. There are several other statements related to it. So this if you know is about this, it's sufficient. So thank you, students.